Hello everyone, this is Gabriel Barahona and today I'm here with Curtis Jennings and this is our ninth project update. We're going to do a demonstration of our MAS model for our final project for ENGI 460. Okay, so first of all we're going to show how we changed our code in order to demonstrate our MAS model of search and discovery of chemical hazards in a manufacturing environment. So the first thing I want to show you in our conference paper, the model we selected as a Mason foundational model is the ant foraging model. And the main changes we wanted to do is we wanted to add multiple spills as well as we wanted to add a manufacturing environment graphical representation in which there would be workshop stations located. So now we're going to run this code and we're going to show you guys how we change our model in Mason to replicate our model in our paper. So first of all, as we can see, these are the 20 robots and the spills are bigger as we change the size of the spills, and the robots detect both of these spills, and as we can see, the robots quickly go from the spill back to the home base to clean up the spill, and once one of the spills has been cleaned, they proceed to the other spill. And as we can see, we made a graphical representation of manufacturing facility, and this is the main manufacturing line where there's three main workshop stations that represented by circles, and there are spills located near the workstations because that's the area where there will be most likely a chemical spill or a industrial hygiene hazard. And these two lines beside are other workstations that support the main workstation line.
Within our MAS model, we want to look at sub-optimization techniques and determining how we could make the robots go from the spills to home in the shortest route. So when we look at the simulation, you can see that the robots have found both spills. However, when we ran this, they found the spills, and other robots may have returned to the home base in a different path. But basically, the robot code deals with a local behavior of each robot entity, and it provides an algorithmic code with a Boolean variable when, if the robot detects a spill, then the Boolean variable is true. Then it applies a greedy neighbor algorithm. So essentially, these robots pick the shortest path based on that algorithm to get back to the home base, and that is our sub-optimization technique that we're using in our MAS model. So now we're just going to discuss some of the challenges that we ran into, which are really areas of improvement that we could make within our MAS model. So when we run this simulation, the robots, they detect both the spills, and there's a first set of robots that find the spill and make their way back to the home base, and then there's other robots that have found the other path, other spill, and do the same thing. However, we would like for the robots, when they detect the spill and clean it up, to return to their home base and essentially discontinue the simulation. They would basically just return to home base and stop.